and also the same root. So we couldn't add these two if it was a cube root of 8 and a square root of 50. We also cannot add them if these two are different, the 8 and the 50. They have to be the same number underneath.
So they have to be the same number and they have to have the same root?
Yes. So what we're going to do here is we're going to simplify what's underneath each radical and then see if we can add them together. And we know how to simplify this one, right? We would replace the 8 with what? I'm sorry, hold on. Yes, 4 and 2. Because 8's not a perfect square, right? But what are perfect squares that can go into 8? 4 and 2. So we'll write 4 square root of 4 times 2 plus 3 square root of, and 50 is not a perfect square, but what's a perfect square that can go into 50? 25, good. 25 times what? 2. Good. Any questions about that part? Why did I pick perfect squares? Okay, but why didn't I pick perfect cubes or perfect quartic roots? Good, because there's a 2 on the outside. Alright, so from here, how could we simplify this? We can take what? Square root of 4, which is, and we're going to bring it on the outside with this 4. So we'll have this 4 times 2 square root of 2. Again, I took the square root of 4, which is 2, brought it on the outside with this 4, and what did I have to leave underneath the radical? 2. Alright, on this one I'll have 3 on the outside. I can take out the square root of what? Which is 5. And what's left underneath the radical? 2. Now let me clean up the outside. So this would be what? 8 square root of 2 plus 15 square root of 2. Notice now how they have the same root and same number underneath the radical. So we can add them now. And when we add them, we just add their coefficients, leave the radical the same. What's the coefficient of this one? 8, and this one? So 8 plus 15? 22, and we leave the square root of 2. Oh, it's 23. 23 square root of 2. That's it. That wasn't too bad, was it? Okay. Questions about that one? Alright, next one. So can we subtract these? No, they have to have the same thing underneath, right? Do they have the same root already? Yes. Alright, so what are perfect squares that can go into 98? 2 and what now? 49. Okay, so we can break this up as 2 times 49 minus 2 square root of, perfect, 16 times 2. Any questions about where I got those numbers?
You said you can only add them if they have the same root and the same amount?
Yes, the same root, so the same number on the outside, which they do, they both have 2. And then what's underneath the radical has to be the same in order for us to add them.
So it doesn't matter about the coefficient?
No.
Okay.
Alright, so from here, what can we take out?
7.
7, good. And we'll have what underneath the radical?
2.
Good. Right here would be minus 2. What can we bring out with the 2?
4.
4. And what's underneath the radical? 2. So this is 7 square root of 2 minus 8 square root of 2. Do they have the same thing underneath the radical now? Yes. So what would be my final answer?
-1.
Good. Negative, and I don't have to put 1, right?
Oh, you don't?
Square root of 2. We know the 1's there automatically.
Negative square root?
Yes, because it's a negative 1. 7 minus 8 would give us a negative 1. Any questions about those? Alright, let's do one more together. So, Jackson, tell me how to break up this one. It'd be 5 square root of what?
4 and 3.
Good. No, no, no. Okay, 9 and 3. And Evelyn, what would the last one be?
265.
Okay. Any questions about how we got those numbers? Okay. Yes, go ahead.
Why couldn't you use 2 times?
That's a good question. Why couldn't we use 2 times 6? We're trying to break it up so that we can take the squares of something, right? So can we take the square root of 6? Can we take the square root of 2? No, that's why we can't use those two. One of them has to be a perfect square. Alright, so Dylan, tell me what this one would look like when I simplify it.
I thought you would have the same number under the
You do. We're not done simplifying.
Oh.
So tell me how to simplify this one. Good. Alright, Chloe, tell me how to simplify the next one.
2 times 3 square root of 30.
Good. Bersida, this one. This is 2 and 64 on the inside, right? So what's the only one we can take the square root of? So we can bring what outside? And what has to stay underneath? Good.
Is there a -1 outside the
This one?
radical, or is that just a negative?
Yeah, this is -1.
I thought we all had to do the same root.
We'll talk about it. Alright, so CJ, this one will be what? Jared? Alright, this one we can't really do anything with. Alright, so like y'all said, we noticed that 2 of them have the same root and same thing underneath the square root, but one of them doesn't, right? That just means we can't combine them. They're not like terms, so we're just going to bring this one down. With these, we can combine them. We'll have what? That's it, and that's as far as we can simplify it. Because these are not like terms. We can't combine them. Alright, how do we feel about those? Pretty easy? Alright, that's just adding and subtracting. So you've done both of them. Now multiplying radicals. So let me move over. The first thing you're going to do is always multiply what's on the outside of the radicals together first. So what's on the outside of this one? That makes 24. Good. In order to multiply them together, they just have to have the same root. That's all. And these both have a root of what? 2. So we can multiply them together and put everything underneath one radical. It's not there, but we know if it's not there, it's a square root, so it's always going to be 2. So let's multiply our coefficients first, so 8 times 2. Alright, what would be c to the third times c? Good. You add your exponents, right? And this would be d to the what? Good. Questions about that part?
So all you doing is just adding the variables?
Yes, just adding their exponents. So 3 plus 1, 5 plus 3 is 8.
You multiply like the coefficients and add the
Mm-hmm. Very good. Alright, so we leave the 24 on the outside. And now let's take the square root of everything we can. So what's the square root of 16? And let's put our plus or minus out here. Why do we need plus or minus? Good. We can mark out that. What is c to the 4th over 2? And this would be d to the... Good. Now all we have to do is multiply those leading coefficients together. So 24 times 4? 96 plus or minus 96. C squared d to the 4th. That's it. Not too bad.
How come you drop the square root altogether?
Because on this one, or you talking about from here to here? Because we took the square root of c to the 4th. So once you take the square root of it, you can move it out of the radical. Any other questions? Alright, next one. So what would I get if I multiplied my coefficients together? 6, and this is the 4th root of 16, x to the y to the... Good.
So you just keep that 4 just the same until you do nothing with it?
Nope, not yet, until we take the fourth root. Yes.
What do you do with the exponents on the 2 and 3?
Talking about right
Are
here?
those 4th roots for the radical?
Yeah, this is for the radical.
I thought that was like 2 to the 4th.
Oh, gotcha. Alright, now we just take the fourth root of everything we can. We leave the 6 out front. And what is the fourth root of 16? Plus or minus 2. X to what power? Second. Y to the first. Good. Alright,
Used on
let's...
the 4th root, or the, whatever you just did to get 2.
You just take 16, and what's the exponent of 16? And the root. So in your calculator, you type in 16 raised to the 1/4 power to get 2.
And why is it plus or minus?
Because it's an even root, the 4. So this will be plus or minus what? 12 x squared y. Am I missing anything? Around which one? Yes, the y. Because this is an even power, even root, and it made an odd. Very good. This is pretty easy. Kinda. Okay,
Do we have to fold this next one?
we do. Any questions about that one? Alright, how did you know we had to fold on this one, Seth?
Because there's 2 binomials.
There's 2 binomials. Very good. So my first terms are this one and this one, right? Alright, and when we multiply radicals, again, these have the same root, right? So we're going to multiply what's out front first, which is what? 6 times 2, 12, square root of 3 times 5, which is 15. Questions about that part? My outside terms, 6 square root of 3 times 4 square root of 2. So what's my coefficients multiplied together? 24. What's underneath my radical? 6. Good. The outside term, so 6 times 4, 24. 3 times 2, 6. My inside terms, this is a negative 5 times 2 square root of 5. So the negative 5 is being multiplied by what? The 2, which is what? And the square root would stay 5. Good. Last one, we have negative 5 times 4 square root of 2. That's going to give me what? Perfect.
Can you repeat that last one? You got it.
Yeah, negative 5 times 4 square root of 2. This has to have a radical, so it's just negative 5 times 4. Negative 20 square root of 2. Before we're done, can we simplify any of these?
Well, no.
No, why?
Because none of them are square roots.
Good. There's no perfect squares that go into 15, none that go into 6, none that go into 5, none that go into 2. We're done.
Do they always be different like that, or
Not
do
always.
the square roots match up?
Sometimes you'll have the same thing underneath the radical, and you can combine them.
So don't we like kind of like solve both of them and like you can take the square root of it?
Yeah, like if this is square root of 18, we could break it up into 9 and 2, right? And we'd have to simplify it.
Could you add the like terms if it was like square root of 6?
If these had the same thing underneath, yes, we could.
Okay.
Alright, next one. And this will be our last problem today. We're going to do 1 through 3 on the bottom right here tomorrow, and then the rest of class will just let you take your checkpoint. Let me focus. This thing is so temperamental.
Will there be dividing on the checkpoint? Like the last
Let me see. No. There will not. It'll just be on your test coming up. Okay. So this last one, what are my first terms going to give me if I multiply them? 28 square root of. Good. Inside, or excuse me, outer terms. 21 square root of. Perfect. Stop me if y'all have a question or don't know where we got something. Inside. Good. Last one.
Negative 9 square root of 36.
Very good. Now here we have some we can simplify. Any questions about how we got those numbers before I start moving on? Okay. Then let's look at this first one. 28 square root of 12. Can we simplify that?
Yes, 4 and 3.
Yeah, 4 and 3 can go into 12. So we'll have 28 square root of what? 4 times 3. Before we simplify it, let's look at the rest of them. Any perfect squares that can go into 24? 4 and 6, good. So plus 21 square root of 4 times 6. What about 18? 9 and 2, good. So minus 12 square root of 9 times 2. And what about this 36?
It can be already. Oh,
Good, 36 is already a perfect square, right? What's the square root of 36? So we'll have minus 9 times, and we'll go ahead and put that 6 there.
Can you explain the last part?
This one?
Yes.
36 is a perfect square, so we don't have to break it up. We only break these up because these are not perfect squares.
Just bring it straight to its square root.
Yes. Alright, moving on. So this will be 28 times what? 2, because the square root of 4, and then square root of what? 3. Plus 21 times square root of, minus 12 times square root of, and then what's 9 times 6?
54.
Alright, so starting from the top, what's 28 times 2? 56 square root of 3 plus
42.
square root of 6 minus 12 times 3
36.
square root of 2 minus 54. Alright, can we combine any of these? Because they have different
yeah.
numbers under the square roots, right? So we're done?
What if one of the numbers underneath one of the radicals is like, could be breaking down?
Yeah, if this was 36 square root of 6, you could do 42 minus 36.
What if it was like square root of 9, then you could bring out the 3?
Mhm. Then you just multiply it just like we did here. Alright, y'all can pack up. Remember that these are the things I'll be checking tomorrow. Bell ringers. Tomorrow you should have 7. Tomorrow you should have 7. And then your homework, it'll be 1 through 20 except for 7, or 5, 6, and 10. Hey, go ahead and mark out 17, 18, 19, and 20 on your homework. We didn't get to those today. I'll put the homework sheet under here so you can see which ones that are marked out.
Can I borrow some?
Yes.
Yeah, I think it was black. Can't get it. Miss Gordon,
Yes,
you're still recording.
thank you.